Hey guys, this is Mr. Bennett again. This is part 2 of video 4-2. Hopefully you took a break. Now you're ready to finish up. And we are going to talk specifically now about the difference between orbital notation and electron configuration. Talked a little bit about it so far. The big thing you need to know is that, the big difference really, is that the orbital notation uses arrows to represent electrons, so an up arrow or a down arrow, and electron configuration we use numbers to represent the electrons. So numbers like 1, 2, 3, etc. However many electrons there are, that's the number you use. So for example, and these lines kind of came out a little weird. So this is supposed to be one orbital because the s sublevel has one orbital. This is another because again s has one orbital. P's have 3 orbitals, so 1, 2, 3. This s has 1, and then this p should have 1, 2, and then this one orbital got really long. But you get the idea. So if I were to fill this in, the s can have 2 electrons, and remember, according to Pauli exclusion, one needs to be up in spin and the other needs to be down in spin if they're occupying the same orbital. So 2s would be the same way. 2p, I fill in 1, 2, 3. We're following Hund's rule here. That's the movie theater rule. We fill in 1 electron to each spot before we double up. When we do double up, we have opposite spins. Okay, so here I have 6 electrons in that 2p sublevel, and they have opposite spins. Then I move on to 3s to fill this one up. I go up arrow, down arrow, and then for 3p, let's say that we need to put 5 electrons here. So we go 1, 2, 3. I put 1 electron in each orbital. Now I have to double up. Okay, so I have opposite spins, Pauli exclusion principle, right? So that's 5 electrons. So grand total of 2 plus 2 is 4, plus 6 gives us 10, plus 2 more electrons gives us 12, plus 5 would mean 17 electrons represented here. So this atom has 17 electrons. We could actually find out the element itself, because if this is a neutral atom, it will also have 17 protons, and then those 17 protons correspond to the atomic number. So we could look up atomic number 17 on the periodic table, and that would tell us this element. Now to represent this in electron configuration, I would simply take the number of arrows in each sublevel and I would write it as a superscript. So in other words, it would be 1s2 because I have 2 electrons here. Then I would go on to 2s, 2s2, then 2p. Our 2p in this case contains 6 electrons, so I put a superscript 6. 3s in this case has 2 electrons, so I put a 2 up here. The 3p contains 5 electrons, and so I would put a 5 up here. Okay, so the electrons are represented by these superscript numbers here. The thing you need to remember is that s's can only hold 2 max, so an s sublevel can only hold up to 2 electrons. P's can hold up to 6, and if we had a d, remember d's can hold up to 10 electrons. Okay, but we didn't need to in this case because we only filled up to the 3p. Right. Another thing you need to remember is the orbital order. In other words, it always goes, we always start with 1s, then we go on to 2s, then 2p, then 3s, then 3p, and then this is where that little exception occurs because of the overlapping of orbitals. The 4s gets filled before you go on to the 3d, and then you go up to the 4p. Okay? Alright, so let's do a little bit of review. I'd like you to do this on your own first. Okay, and then come back and check your answers. So pause the video right now and see if you can do this. Hopefully you pause the video. Okay, so the s orbital, how many electrons can it hold? Well, s orbitals only have, well, s sublevels only have 1 orbital. So one orbital can hold 2 electrons, 1 up spin and 1 down spin. So again, that would be 2 electrons. That's your answer. Okay, the p orbitals, well, each p sublevel has 3 orbitals. So that means 1, 2, 3, 4, 5, and 6 electrons, so 6 electrons total. The d has 5 orbitals, so if there's 2 electrons in each of these, then that means the d sublevel can hold up to 10 electrons in its orbitals. F, okay, notice there's a pattern here. S had 1 orbital, p had 3 orbitals, d has 5, so we're adding 2 each time, or we're going up by odds. So that means that the F sublevel has 1, 2, 3, 4, 5, 6, 7 orbitals at 2 electrons each. That means F can hold up to 14 electrons. Okay, so now let's talk about what the electron configuration for an element would be. And in this case, we're going to use magnesium as our example. If you're asked what the electron configuration is, the first thing you need to do is figure out how many electrons it has. If it's neutral, that means that you can look up the atomic number, which in the case of magnesium is 12. Okay, so that means 12 protons. And since it's neutral, it would therefore have 12 electrons to balance. So to do the electron configuration real quick, is that arrows or does that mean numbers? Orbital is arrows, electron configuration is numbers. So what that means is we go, okay, 12 electrons, so I'm going to fill up my 1s first, it can hold up to 2 electrons. Then I go on to my 2s, it can hold up to 2 electrons. Then I go on to my 3s, oh sorry, I messed up, right? Not 3s, because the first energy level has an s, second energy level has 2 sublevels, the s and the p. Fill up the p with 6 electrons because it can hold up to 6. That's 2 plus 2 is 4, plus 6 gives us 10, right? Then we go on to the 3s, okay? 3s can hold up to 2. Let's count them up. 2 plus 2 is 4, plus 6 gives us 10, plus 2 gives us 12, which is exactly what we wanted. So this is the configuration for magnesium. Don't mess up like me. Make sure that you go 1s, 2s, 2p, then 3s. Second energy level has 2 sublevels. Little trick, when you're done, add them up. Make sure that they add up to the number of electrons you're supposed to. Always double check. So 2 plus 6 is 8, plus 2 is 10, plus 2 gives us 12, which is what we wanted. Alright, practice again. That means try this on your own. Okay, you're going to pause it in a moment, and you're going to try it, then you're going to come back and see if you get it right. So pause it now and try. Okay, so if you did this, that means that you're looking for sulfur. Sulfur is over here. It has an atomic number of, I'm going to abbreviate that as AN, it has atomic number equal to 16. So that means if it's neutral, it also has 16 electrons. Okay, orbital notation, that means arrows. So up arrow or down arrow for the electrons. So we go 1s, that's going to get filled with 2 electrons, up and a down. Then we go into 2s, it has 1 orbital, 1 electron with an upspin, 1 electron with a downspin. Then we go into 2p, which has 3 orbitals. Each one can get an electron. Before we go back and double up, then we put in our downspins. Okay, so that's 2 plus 2 is 4 electrons, plus 6 here gives us 10. We need to get to 16, so we keep going. After the 2p, we go on to the 3s, which can hold 2 electrons. That gets us to 12 electrons. Still need to get to 16, so we need to go on to the 3p, which is 1, 2, 3 orbitals. We need to put 4 electrons in here, so I put 1 in each, and then I go back and I double up. Let's count just to double check. 16 electrons is what we need. So this is 4 plus 6 gives us 10, plus 2 gives us 12, plus 4 gives us 16. So that's good. To do this in electron configuration, remember is the numbers for the electrons. So we simply go 1s2, 2s2, 2p6, 3s2, and then finally 3p4. Okay. Double check, add them up. That's 4 plus 6 is 10, plus 2 gives us 12, plus 4 gives us 16 electrons, which is what we want. Notice, orbital notation will tell us the spins, upspins, downspins. Electron configuration is simply the number of electrons in each sublevel. Okay, less information. Alright, now what happens if we go the other direction? In other words, what if they give us the electron configuration and they want to know what the element is? Well, there's really 2 ways you can solve it. First way is you can add up the electrons. We simply go 2 plus 2 plus 2, which would give us 6 electrons. And if this is a neutral atom, that means we'll have 6 protons, which means that its atomic number is equal to 6. So if we go through here and we look for atomic number 6, that means this is carbon. Okay, so that was adding up the electrons. Now the second one sounds like what we just did. We found its location on the periodic table. But specifically tomorrow I'll show you how to map out the periodic table and do a little faster method. But we're not going to worry about that tomorrow. For right now I want you to practice this way. Okay, so going backwards, I want you to, again, you're practicing now, so that means look at these, okay, see if you can figure this out, each element on your own, okay, and then come back and see if you got it right. So pause the video now and try and see if you can solve it. Alright, hopefully you paused it. So let's see, we're going to count up the number of electrons. Here we have 2, here we have 2, and over here we have 2 plus 2 is 4, plus 1 is 5. So 2 plus 2 plus 5, which gives us 9 electrons. So if we go through here, that means 9 protons, which means that's our atomic number. Okay, so atomic number of 9 is fluorine. Now for our second element here, we have 2 plus 2 electrons here plus 6 electrons, 6 in the P, okay? Then 2 here in the 3s, and then 1 in the 3p. So 2 plus 2 is 4, plus 6 is 10, plus 2 would give us 12, plus 1 would give us 13 electrons. That means that it has 13 protons if it's neutral, which is also the atomic number. So we go through here, we find atomic number 13, which is aluminum. Alright, hopefully you got those correct. You're done with video 4-2. Make sure you complete your whisk, and I'll see you tomorrow.